Okay, Daniel and Madison, I just realized I missed a question from each of you. Madison, I think I missed yours because I think you actually meant 4B. I think you meant 4B, just given by what you wrote in your question. And Daniel, you needed 2D. So let me see if I can get both of these. They're different questions, but I wanted to just clear them out at once because they're both actually not real long. Madison, you're confusing the two numbers a little bit. Let me see if I can make sure. I'm going to try to explain what's happening. You got the A, but you were confused about the B. Let me see if I can explain it. We know that if the average, if it's a differentiable function, that we know that the average slope from 7 to 5 is 5 halves. Somewhere on the interval between 7 and 5, the derivative has to be 5 halves. What we're doing is we're estimating that must be 6. Well, let's just say 6 is halfway between. That doesn't mean that means 6 is actually the exact answer. They did ask a very similar question, but make sure you don't confuse the two 2's. That it kind of sucky that they picked 2 as the answer, and 2 happens to be between. It's not between there, but that 2 is not the point. What they're saying is same thing. Between 5 and 3, if you put those in, you're going to get a slope of 2. If you use the y2 minus y1, just like you did y2 minus y1 here. You got a slope of 5 halves, you got a slope of 2. What we're saying is that somewhere on the interval between 3 and 5, the slope has to be 2. Somewhere on the interval, the slope has to be 5 halves. This 2 is the slope, doesn't have to be between the 5 and 3. Matter of fact, it won't be between the 5 and the 3. But like for example, we could be 4. Okay, so again, that 2 doesn't refer to the x value. That refers to the slope. The average slope is 2. Therefore, we know that the somewhere between 3 and 5, the derivative does have to be 2. Whereas in the first one, we know that somewhere between 5 and 7, the derivative has to be 2.5. And we just said, okay, well, that's how we're going to use to approximate 6. And then, Daniel, your question was 4D. When will the velocities be the same? What was a little weird about this question is they gave you the velocity of the first particle. They gave it to you, and you should have it in y1. Put that in y1. And you probably did that earlier in the question. And then they give you, at the very end, they give you x, which is the position of something. You need to know that the derivative of the position is the velocity of the second function. So now you have to do that one by hand because they gave that to you here. They didn't remember they gave us x in the question. They didn't give us the velocity. So they give you the velocity of the first one very early in the question. They don't give you the velocity the second, they give you the position of it, but it's pretty easy to take that derivative and you get 2x minus 1. And then you have to put that in y2 on your calculator. And then what you do is you want to look for the intersection point. And I forgot what that intersection point is, and that's what they want for the answer to that one. So the answer to that one, hold on, I'm a little lost here. Alright, I was on a different page here, so I gotta kind of look it up. Where do those two graphs actually intersect at? They actually intersect at t equals 1.571. That's when that original v would intersect with the 2t minus 1. Now you had to figure that out because they gave you the displacement, and just be aware that the derivative of displacement is velocity. And then just double checking back on number 2. Just make sure I answered that question right. Or number 4, sorry. I went the wrong way. I was going up instead of down on my answer keys thing here. Yeah. So again, notice that the slope in the first one is 5 halves. The slope in the second one is 2. We're using that we're saying that the derivative at 6 would be that. What they're saying in the second one isn't that the derivative at 2, is that somewhere between 3 and 5, there has to be a derivative that equals 2. Not that we're finding the derivative when you put 2 in here. This is that we're saying that the derivative has to be 2 for some number between 3 and 5. We just don't know what number that is. Okay, sorry about forgetting that the first time through.